different way of hopefully lining up the motor pulley, because I just realized to try and take that guard off, because I mounted the oil water separator on that side here. I'm using a turnbuckle to hold everything together, and I don't really want to take it all apart. So I'm going to see how close I get first. If not, I guess I'll have to take the guard off, but it'd be no different if I had to put belts on. So, all right. There we go. Of course, I got one bolt kitty wampus. Loosen all the up here. All that work. As long as I got it slid over, I'm gonna pop a nut in the washer on there. And then I can't. I do remember now struggling with this. It's all coming back to me now. It's all about working with the fingers. There we go. Not a whole lot of space to get to it. And then to top it all off, I managed to put a burr in the bolt. We're doing good. I don't know if you guys ever watch the YouTube channel from One Lonely Farmer. He's got some interesting techniques that are pretty much real world reality. He was replacing a turbocharger on a John Deere 7410, and anyways, he beautiful. He had a hard time getting on a grip on a bolt, and he actually got really creative with it. He actually had gotten I think it was a skinnier box end, and what happened was it was spreading, so he actually tack welded it to the bolt and broke it loose, and broke off the weld, and everything was good. And some days you have to do stuff like that because you don't know as far as what the next step is until you get there. So growing up on a dairy farm, we've been there too when we were farming. There was just some things that rather than pay someone else to do it, it was cheaper to do it yourself, even after all the blood and sweat you did trying to get it done. So, okay, we're gonna slide this motor over and get the belts on. That's the outside one. That's the inside one. Okay, now we need to get this guy positioned, and what's here? Now, if this was more nuts and bolts, I'd get a ratchet driver, but I'm not going to. Shut that one. Bumble fingers. Okay, now I got some custom swearing to do because I gotta try and line these pulleys up, or the pulley up with the grooves in the compressor. So I'm gonna do that. You guys take a break, and Anyways, the next step is going to be I'm going to line the pulleys up, tighten the motor pulley down, then we're going to hook it up. Then we're going to fire it up and see if it works. Okay, I'm back. Got that straightened away. Ain't going to tell you how I did it. Don't want to talk about it, but anyways, just looking at the instructions on the motor here, the wiring diagram. We've already got the wires together where they need to be. But I'm looking at the schematic here as far as which direction here. It says standard rotation is counterclockwise facing and opposite shaft extension. So counterclockwise means it's turning this way. And I need it to turn this way, not this way. So to do that, I need to run opposite direction, which means I need to do 5 and 1. See, this is 5. No, that's 1. And 5. There we go. So the blue and black are going together. And then the yellow and red are going together. A single voltage, single phase motor, it's pretty easy to wire. Can't really mess it up. Okay, now to deal with this. Oh yeah, this one has a big knockout too. So, just like the other motor, I didn't see that. You have to use these hole adapters, I call them. I don't know what the real name is, but basically the way it works is it's got a smaller hole, but this rim here fits in the larger hole in the box. So this one in here first. Here's it back through here again. There you go. And I think the reason they do that is because this motor draws over 20 amps, you should be running number 10 wire, which this is here, but theoretically a lot of, especially like OEM, like a compressor manufacturer for example, they'll probably only run number 12 gauge wire from the contactor to the motor because it's such a short distance. Okay. Screwdriver and tighten this guy up. There we go. Alright, now first I'm going to hook the ground up, and there is a grounding lug in the motor here, and you can see this one a little better. Now as far as which wires, it doesn't really matter because both of these lines from the starter are hot. Not right now obviously, but they will be once I kick on the switch here. I'm going to leave the conduit box off for a second and make sure that all this is tight. Okay, let that there. I'm going to go bleed off some air here first and we'll come back. Alright gentlemen, moment of truth, here we go. Beautiful. Alright, the one thing I'm going to do is I want to check the running amps on this compressor. The whole idea, part of the idea of this is that we were going to be able to speed this back up a little bit, get it back to its original RPM, get a little faster recovery without going over the motor's amps. Being this motor is a 1.15 service factor, I'm supposed to be able to pull up about 26.5 amps because it's got a full load rating of 23 plus 0.15% or 15%, so it comes out to about 26.45%. So, okay, all right, let's get on this leg right here. And here we go.
Weird. She's falling. Boy, that is weird. It's pulling 27.5 amps, pulling 1 amp more than what it should be. Let's take a look at what this other one's doing. Yeah, it's about the same.
Scared the out of me. Hey guys, just wanted to come back here and check the running amps again. Unfortunately, when I was doing the initial install, when I went back to go edit my videos, I didn't, my camera wasn't recording for a reason, probably operator error, recording the second amp reading that was more accurate than the first. So also during that time, I did speak with the distributor that I've been getting my Quincy parts from, and he was telling me on the ROC10, well, maybe this is the ROC10, but he was telling me that a 175 psi machine would use a pulley inner pitch diameter of 7.0, and a 150 psi machine would use a 7.4, and this actually is a 7.4 pulley. So I've actually moved the pressure switch down to 150 psi cutoff, and I didn't really see a significant change on the amp draw, but I just wanted to pull another amp drawing here just to verify actually what I'm seeing here. So I'm going to pull off the top side here, use my multimeter, and should be good to go here. All right, here we go.
That's more in line. About 24. Out here very shortly.
Yeah, so it's right where it's supposed to be. I could crank the pressure up a little bit back to 175. I think it'll pull it, but the guy was telling me at the distributor where I get my Quincy parts from, he was telling me that like I said, 175 psi unit was fitted with a pulley inner pitch diameter of 7.0, not 7.4. So when I originally got this compressor, the pressure switch was set up for 90 to 120, which was kind of on the low side. So I did replace the pressure switch when I got it as well, so I got a new square D there. The only thing I don't like about the pressure switch is that it has a 40 psi differential, and it's non-adjustable. So it's 40 psi, so I guess it'll keep the compressor from cycling as much. It'll just run a little bit longer to make it for the extra 10 psi. So anyways, there we have it. So I did confirm, this is like the 4th reading now I've taken. First one actually, or first accurate reading on camera here. So we're pulling about 25 amps. So the motor itself is good for 26.45 with the service factor of 1.15. So it's a 23 nameplate, and then like I said, 1.15 service factor, which brings you to about 26.45 amps to be exact. So anyways, I just wanted to share it with you. Like I said, I had originally did this before when I set the compressor after I saw that first reading, which you actually saw earlier. And for some reason I just thought that was way too high. So but we're right where it's supposed to be, so it's good news. So anyways, this is a fun project, so hope you guys enjoyed it, and thanks for watching. About 160, not quite.